This is one learning outcome from the IB Higher Level Mathematics Function Topics syllabus. And this is a formula related to it. So a student's question was, what does it mean? Am I ever going to need this formula? To exemplify in which cases you need to use the previous formula, we chose this question from the further math paper, a specification. And the statistics syllabus in the further math course is exactly the same as your option topic syllabus. So please pause the movie and read the question. In some of the previous examples, we found a correlation coefficient in the case when the values of the two variables w and h were given, and we would insert them in our graphical display calculator, which will give us in return the correlation coefficient. In this case, some statistics are given about the height and the weight. So we are going to need this formula, which is copied from your formula booklet. So we will need a bit of a matching here, and let us consider that the w is x and the height is y. So in my formula, I see I have sum xi, yi, which is actually sum of wh, which is 34150. I also have the mean of x, which in my case is the mean of w, and it's 340, the sum of all values divided by the number of values. The mean of y, which in my case is the mean of the heights. The sum of the heights is 2002 over 20. What do I need in the formula is the sum of the squares of the value, which in my case is sum of weight squares, which is 5830, and sum of the squares of y, which is sum of h squared, which is in my case 201124. So now I'm ready to replace all this in the formula. Probably the most confusing part was matching x's and y's with w and h. And this is what we get after replacing in the formula here all the values that we found. So the correlation coefficient is 0.610 to 3 significant figures. We'll be now looking into calculating the p-value of our result and interpret it at 1% significance level. So, using the t-test, we found the t-value using this formula, that's from your formula booklet. So the t-value is 3.264 to 3 significant figures. Now, the t-distribution will look like this. This is your t-value, and you need to decide on the p-value, which is this area. So I'm going to calculate using TCDF in my GTC, that area. So using TCDF, the area to the left is this value. Therefore, the p-value is this one here. So the p-value is 0.00216 to 3 significant figures. The p-value is smaller than 1%. Therefore, there is a positive association between h and w. And here is all our work on question A. We are going to move now on question B. For question B, we are asked to find the equation of least square regression on W on H. And again, this will not be given by our GDC, so we need to use a formula. So from this one, the more challenging thing here is to match the variables and make sure that we don't use them in the wrong position. So in my case, x will be W and y will be H. So the equation, the regression line equation will be, in my case, W. Okay, so after replacing, this is what I got for the regression line, and after using basic arithmetic, we change it into W equals 0.160H plus 0.957. Now, second part is easy. For H equals 90, after replacing, we find W equals so W is 15.4 to 3 significant figures.